Hello everybody, this is Mr. Yen, and in this video I want to go over from lesson 7.5C from problem 2. I could tell from your classwork a lot of you were stuck on this and not sure, so it's helpful to go through it step by step. Let's start with the given information. We know that quadrilateral ABCD is a rhombus. And the definition of a rhombus is four sides congruent. All sides are congruent. So I can start by marking that here. So A to B is going to be congruent to B to C, which is going to be congruent to C to D, which is also going to be congruent to A to D, A to D. Those are the four congruent sides. I also know this piece of information right here, that angle BAM is congruent to angle DCM. So let's mark that in. BAM. BAM. So that's this angle right here. And then angle DCM. D to C to M. That's this angle right here. The other piece of information that I have is that angle AMB and CMD are vertical angles. So AMB, that's this angle right here. And angle CMD, CMD, that's this angle right here. And if you remember, vertical angles like this, when they're reflected like that, are always going to be congruent. So I know that those two angles are congruent to each other. So now I've marked everything that I can based off of the given information. What do I need to prove? Well, this right here, that diagonals AC and DB bisect each other. Remember, bisect means to split in half into two equal and congruent parts. So this question, if diagonals AC and DB bisect each other, what has to be true about the segments AM and MC and BM and MD? If this diagonal, A to C, and this diagonal, B to D, if they bisect each other, then they have to split each other in half, which means that this half would have to be congruent to this half, and this half would have to be congruent to this half. So the way that I can write that is the AM half, that segment, would have to be congruent to the MC segment, and the BM segment would have to be congruent to the MD segment. That's what I just marked in purple. How can we use congruent triangles to prove this? That AM is congruent to MC and that BM is congruent to MD? Well, let's take a look at our diagram. Based off of the given information, and if we're trying to prove that these two diagonals are splitting each other in half, notice how if we just focus on this triangle up here and this triangle right here, and we can prove that those two triangles are congruent, then we'll be able to prove that these matching sides are also congruent. So we want to prove that triangle, so this top left triangle, that's triangle AMB is congruent to triangle CMD. If we can prove that, so if that's true, then, right, then we can prove that part right there. Okay, so that's what we're trying to prove. I'm going to erase a little bit from this diagram so it doesn't get too confusing. And I'm just going to bring it back to the given information. Okay. So now this was the given information, and we're only focusing on the top left and the bottom right triangles. So I'm even going to erase this side marking and this side marking, just so we can stay focused on the two triangles that we need. All right, so let's start by marking the congruences that we have. We have, from the given information, we know that angle BAM is congruent to angle DCM. That's what we marked in green. I'll write that here. Angle BAM is congruent to angle DCM. We also have another angle. That's the one I marked in blue here. So angle AMB is congruent to angle CMD. And then the last piece of information I have is these two sides, because they're two sides of a rhombus and all the sides of a rhombus are congruent. So I can say now that AB is congruent to CD. And then those two triangles are congruent, the two triangles that I wanted to prove, which was AMB is congruent to CMD. And the reason why, well, we had this angle, and then this side. So it's two angles and A. Now is the side included or non-included? Check one of the triangles. The side is only touching one of the angles. The side is not touching both of the angles. So I'm going to say a non-included side. Non-included side. So the short form of that is angle, side, or AAS. That's the reason. Okay, once you have that, then the conclusion is a little bit easier. And remember, in your concluding statement, you always have to restate what it was that you were trying to prove. All right, that's all. Make sure you check the answer key closely so that you can review all your work. And let me know if you have any questions.